So let's move on to oscillation. Oscillation is a subset of whatever we just saw. So oscillatory motion over here, it looks like this. So it's not able to reach the peak clearly, and we have an arc. So we are trying to figure out a few things over here. So first thing is, for a body to oscillate, what is that we're looking at? So let's write it off. For an object or for a body to oscillate, the velocity of the object should become what? Should become 0. But it has to be prior to, that is prior to the tension in the string becomes 0. Again, so basically, let me put it this way. I don't want the bob to go somewhere over here and just drop. Okay, it should not be that. It should not go like this and stop over there. Or it can't go like that and drop in this manner. It should not be that. There has to be a proper, as if it's attached to a rod, So as if it's attached to a rod, but it is thread basically. The pull has to be so strong at this end and this end, so that the rope is, or the thread is strong, tight, not strong, sorry, tight. That has to be the condition, right? So with this as the basic condition, basic understanding. So let's figure out 2 or 3 points. Let H1 be the point where the velocity, we are dividing and conquering, where the velocity of object, in this case body actually, becomes 0 meter per second. So we know that we have v square is equal to u square minus 2 into g into h. So we are substituting h is equal to h itself. No, h1, we're calling it as h1. And then that's it. There's nothing else to substitute. So we have v square is equal to u square minus 2 into g into h1. That's your simple expression. So we have h1 is equal to v square, actually u square, and no, wait. Okay, v square, if I transpose that and this, no, it is u square minus v square by 2 into g. So basically it is u square by 2g. Let me rewrite this way. Sorry, I confused you guys. V will be equal to 0, right? So if I do that, this is 0 and you have u square by 2g. Okay, so this is the case. Now let's move on to the next case. Let h2 be the, actually it should be the height, my bad, height, let me change it so it's consistent. So we are expressing all this in terms of height, remember, that's what the entire derivation started with, where tension in the string becomes 0. So we are ignoring other condition, we're just looking at it. So tension is given by M by R. This, guys, I have a formula in front of me. I'm just copying from there. Minus 3GH. Right? So at H is equal to H2, your tension will become 0, and that's it. So let's figure out H2 value. So 0 is equal to M by R U square plus GR minus 3GH2. So we have H2 to be equal to U square, this and this will kind of cancel, plus GR, this entire expression divided by 3G. Now we have H1, we have H2. What should we do? Clearly H1 has to come before H2, or H2, the value has to be more than H1. Is it not, guys? H2 has to be greater than H1, or at least equal to H1. That's the maximum possibility. So let me put it this way. For the asked condition, for the asked condition, that is oscillation, actually, for the oscillation, actually need not have the word thou over there. We need to have H1, it has to be less than or equal to H2. That's the whole point. That's the very first statement. So this is U square by 2G, which is less than or equal to this expression U square plus GR by 3G. So we have G and G getting cancelled. Then we have transposing 3U square less than or equal to 2U square plus 2GR. And if I transpose this, you have U square, or U is less than equal to root of 2GR. So that would be your condition. Okay, yes. So that would be a condition for your oscillation to happen.